Welcome back. Today we're going to be working on one of my favorite lessons of the entire year, which is the Pythagorean Theorem Day 1. Content objective is students will be able to use the Pythagorean Theorem to find the missing side of any right triangle. Language objective is students will be able to explain how to find any missing side of a right triangle using the Pythagorean Theorem. Why am I learning this? Well, it's important for real-world problems like finding the distance between home plate and second base on a baseball field. So a long time ago, there was this Greek mathematician named Pythagoras. He is responsible for discovering a very interesting property about right triangles. He figured out that the sum of all the squares of the lengths of each of the triangle's legs is the same as the square of the length of the triangle's hypotenuse, which is basically the longest side of a right triangle. This property, which has many applications in science, art, engineering, and architecture, is used now, even till today, which is called the Pythagorean Theorem. So the Pythagorean Theorem states that if A and B are lengths of the legs of a right triangle, and C is the length of the hypotenuse, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So I know that was a mouthful, so let's look at a more simplified version. It's going to be one of the easiest formulas you'll ever have to memorize. It's just a squared plus b squared equals c squared. So now the Pythagorean theorem only works for right triangles, and it's very important that you understand that. Okay, so here, notice this triangle has a little square at the corner of it. This notation tells me that we have a right triangle. So whenever you see this symbol, you know for a fact that it is a right angle. Okay, so in this case, it's going to be a right triangle. Now, in a right triangle, there are two legs, and then there's a hypotenuse. The hypotenuse is always across from the right angle, always. Okay, so this is my hypotenuse. And it's also known as the longest side of a right triangle. One thing that you need to know is that the legs are considered the A and the B when we're referring to the formula of a squared plus b squared equals c squared, and C is always the hypotenuse. Now, another thing to understand is A and B can be switched. So basically, they're interchangeable. So it really doesn't matter which one's A, which one's B. Now, C cannot be changed. C is always the hypotenuse. So again, the Pythagorean theorem states that a squared plus b squared equals c squared. Okay, again, one of the easiest formulas you'll ever have to memorize. So it says here, find the missing length. So once again, we have to remember we're only allowed to use the Pythagorean theorem if and only if we have a right triangle. Do we have a right triangle? Yes, and I know that by this little box at the corner of the triangle. Okay, so the first thing I like to do is identify the hypotenuse. And basically what you're going to do is go across from the right angle and then note that in this case, x is my right triangle. Is my hypotenuse. Once I figured out the hypotenuse, I'm just going to identify the legs, which in this case is 6 and 8. So now I'm going to plug it into my formula, okay? X needs to be plugged in for C because that's the hypotenuse, and 6 and 8 are going to be plugged in for A and B because those are the legs of the right triangle. So here I'm going to go ahead and say A is 6, B is 8, and C is x squared, okay? So again, you can think of it as I am calling this side A and this side B, and that's why I plugged in 6 for my A squared and 8 for my B squared, and of course x is my C squared. Now all you have to do is simplify this. 6 squared is 36, 8 squared is 64, so we have 36 plus 64 equals x squared. You're going to take another step further and simplify. 36 plus 64 is 100, so if 100 equals x squared, keep solving. We're going to take the square root of both sides and find that x equals 10. So to answer the question, I would say the missing, well in this case it's the hypotenuse. The missing hypotenuse is 10. And that's it. Okay, so let's try another one. So here it says again, find the missing length. First, I like to identify the hypotenuse. So again, the hypotenuse is always going to be straight across from the right angle. So in this case, it is y. And then I'm going to identify the legs, which in this case, of course, is going to be my 3 and the 4. So for my formula, a squared plus b squared equals c squared, I'm going to go ahead and make 3a and 4b. For me, personally, I like to pick the smaller number to go with a and the larger number to go with b when I'm referring to the legs, but it really doesn't matter because addition has that commutative property and you're allowed to switch them around. So here, I'm going to go ahead and put 3 squared plus 4 squared equals the hypotenuse, which in this case is going to be y squared. So simplify what I have. 4 squared is 16, 3 squared is 9, so we have 16 plus 9 equals y squared. 16 plus 9 is 25, so 25 equals y squared. Almost done, just take the square root of both sides, and I'm left with 5 equals y. So here, since y is a hypotenuse, I'm going to say the missing hypotenuse is 5. Okay. So now at this stage, I would like you to go ahead and pause the video and try number 3 on your own. Okay, so let's see how well we did. Hopefully you identified that the hypotenuse is b. So you went ahead and left 5 and 12 as the legs. So there you would have, let's see, 5. Here, 12 is a and 5 is b. So here it really doesn't matter, like I said. So you're going to have 12 squared plus 5 squared equals b squared. Now I chose this particular example for you to understand that even though this is called b, I understand because it's across from the right triangle, sorry, from the right angle, it is my hypotenuse still. Okay, because some students may think, oh, this is b, so I'm going to plug it in for my b here. No, this is across from the right angle, so therefore this one's the hypotenuse. So here 12 squared is 144, 5 squared is 25. That's going to equal b squared. 144 plus 25 is 169. So if this equals b squared, we're going to take the square root of both sides and be left with 13 equals b. So b is the hypotenuse. So I'm going to say the missing hypotenuse is 13. Okay. So now let's move on to another type. So here we're going to find that, first of all, let's use a Pythagorean theorem. So we're going to figure out which one's a hypotenuse. Here you're going to find the hypotenuse is actually a number. It's not a variable this time, which is okay. So I'm going to go ahead and put label 5 as a hypotenuse, and I'm going to label 4 and t as the legs. So here we're going to write down our formula, a squared plus b squared equals c squared. You're going to see here that I basically labeled 4 as a and b as t. So I have 4 squared plus t squared equals c squared, which is going to be 5 squared. Simplify what you have, so we're left with 16 plus t squared equals 25. Now see, the only difference here is now we're going to have to try to solve for t squared, so we have to go ahead and eliminate the 16 here by subtracting 16 from both sides, which leaves me with t squared equals 9. And just like before, we're just going to take the square root of both sides, and we'll see here that t equals 3. So in this case, the missing side was not a hypotenuse for this problem. It's actually a leg. Okay, so I'm going to say the missing leg is 3. Okay, so let's try another one. Here, find the missing length. So once again, it's always important to first identify the hypotenuse. It's going to be right across from the right angle. So in this case, it's a 20. So now that would make n and 16 the legs. So I'm just going to plug it into my formula. N squared plus 16 squared equals 20 squared. So in this case, I just considered a as n and b as 16. Again, you can always alternate it. It really doesn't matter which one you can call a, which one you call b. So now I'm left with n squared plus 256 equals 400. Now I want to solve for n. So the first thing is I need to at least isolate n squared. So I'm going to go ahead and subtract 256 from both sides, which leaves me with n equals 144. Almost done. Going to take the square root of both sides, and we're left with n equals 12. Now, Some of you, I forgot to address this, may be wondering, wait, when we're solving equations, when we take the square root, shouldn't there be a positive and negative answer? Absolutely. But let's think for a second. If I were to describe the length of a side of a triangle, would I ever describe it as a negative length? No, and that's why we don't include negative 12 as an answer. It's just strictly 12. Okay, so here, this one is not a hypotenuse. This one's actually a leg. So again, I'm going to say the missing leg is 12. Okay, so now we're just going to try one more. Actually, go ahead and pause the video and try number 6 on your own. Okay, so let's see how well we did. Hopefully you said the hypotenuse is 10. So that makes t and 6 the legs. So here, plugging into our formula, a squared plus b squared equals c squared, you should end up with something along the lines of t squared plus 6 squared. Again, these can be reversed and it doesn't matter, equals 10 squared. Now we have t squared plus 36 equals 100. We're going to isolate t squared by subtracting 36 from both sides, and I'm left with t squared equals 64. Not quite done yet. I'm going to take the square root of both sides, and I'm left with t equals 8. In this case, it is a leg once again because it's not across from the right angle. So I would say the missing leg is 8. Okay. So now at this point, I want you to go ahead and finish the problems from 7 all the way to number 10. Okay, so let's see how well we did. Hopefully you recognize that the hypotenuse is h. So the legs are going to be 9 and 12. If you plug that into our formula, we're going to get something along the lines of 9 squared plus 12 squared equals h squared. Simplify what we have on the left-hand side. We have 81 plus 144 equals h squared. We're going to go ahead and continue to simplify, leaving us with 225 equals h squared. We're going to have to take the square root of both sides, and 15 equals h. So here, h is the hypotenuse. So we're going to say the missing hypotenuse is 15. So hopefully you got that one right. Okay, now let's take a look at number 8. Here, again, you're going to look across from the right angle and see that the hypotenuse is 25. That means the legs are 20 and t. So plugging that into our formula, you should have something along the lines of 20 squared plus t squared equals 25 squared. 20 squared is 400, so we have 400 plus t squared equals 25 squared is 625. So we're just going to go ahead and try to isolate t squared for now. So we're going to subtract 400 from both sides, leaving us with t squared equals 225. Now, simply take the square root of both sides, and we're left with t equals 15. So here, t is one of the legs, because again, whoops, it's not across from the right angle, so it's definitely not the hypotenuse. Oops, let's change colors. So I'm going to say that the missing leg is 15. The missing leg is 15. Okay, 2 more to go. Number 9. Here, the hypotenuse is 13. Therefore, the legs are 12 and t. So plugging that into our formula, we have 12 squared plus t squared equals 13 squared. 144 plus t squared equals 169. We're going to attempt to first isolate t squared by subtracting 144. And that leaves us with t squared equals 25. Take the square root of both sides to solve for t, and we're left with t equals 5. So here, since t is a leg and not a hypotenuse, we're going to say the missing leg is 5. Okay, last one here. The hypotenuse is going to be c, and the legs would then therefore be 12 and 16. So here we have 12 squared plus 16 squared equals c squared. We have 144 plus 256 equals c squared. Add those numbers together, we're going to get 400 equals c squared. So simply take the square root of both sides, and we're left with 20 equals c. Since c is the hypotenuse, since it is across from the right triangle, we can go ahead and say that the missing hypotenuse is 20. Okay, so now that we've learned how to use the Pythagorean theorem, let me teach you something called the converse of the Pythagorean theorem. Basically, it states that for any triangle, If the sides A, B, C turn out to a point where a squared plus b squared equals c squared, then that means the angle between A and B is 90 degrees. Therefore, we have a right triangle. Okay, so let's put this to use. Here, for this question, it says determine whether the given lengths could be the sides of a right triangle. So what you're going to do first is identify, okay, which one's going to be the hypotenuse? Normally, the hypotenuse is the longest side. So I would say, okay, if this was a right triangle, 13 would be the longest side. So that means 5 and 12 is your legs, which is A and B. So just plug it into our formula of a squared plus b squared equals c squared. So here we're going to say 5 squared plus 12 squared equals 13 squared. Simplify what we have. 5 squared is 25, 12 squared is 144, and 13 squared is 169. 25 plus 144, well, let's check it out. What does this give me? 4 plus 5 is 9, 4 plus 2 is 6, 1 plus nothing is 1. So I'm left with 169 equals 169. This is true. So if you end up with a true statement, that meant a squared plus b squared really did equal c squared. So that means we have a right triangle. So we would say 5, 12, and 13 will make a right triangle because it follows the Pythagorean theorem. It follows the a squared plus c squared plus b squared equals c squared. Okay. On your homework, what you're going to be expected to do is to say, is it going to create a right triangle or is it not? And then you're going to be asked to explain why. What I'm looking for you to write down is this statement right here. Okay, so now let's take a look at this example here. It says determine whether the given lengths could be the sides of a right triangle. So once again, you're first going to identify which one's a hypotenuse. Again, that's the longest side if it was a right triangle. So in this case, I would say if it is, it's going to be 12. So I'm going to plug it into my formula of a squared plus b squared equals c squared, which means 9 and 6 are the legs. I'm going to have 9 squared plus 6 squared equals 12 squared. Is this true? Well, let's see. We have 81 plus 36 equals 144. If I add those numbers together, I'm going to get 117 equals 144. This one is false. It does not work. Therefore, it means 9, 12, and 6 will not make a right triangle because it does not follow the Pythagorean theorem. And again, in your homework, as proof, you're going to write in this statement right here that 117 does not equal 144. Okay, so now let's take a look at a couple more examples. I'm going to have you try some on your own. So again, let's just follow the same routine. They're asking us if this is going to make a right triangle. If it is, which one would be the hypotenuse? We're going to call that 8 since it is the longest side. So now we're going to plug that into the Pythagorean theorem. So we have 5 squared plus 6 squared equals 8 squared. So we have 25 plus 36 equals 64. Is this true? Well, let's check it out. 25 plus 36 is going to equal 61. Does 61 equal 64? Nope, that's false. So I'm going to say it will not create a right triangle because it doesn't follow the Pythagorean theorem. Because 61 does not equal 64. Okay, a last example for me. It says determine whether the given lengths could be the sides of a right triangle. Again, we need to figure out if it was a right triangle, which one would be the hypotenuse. So we're going to assume it's got to be 20 since it's the longest side. We're going to plug it into our formula. So here we have 12 squared plus 16 squared equals 20 squared. 12 squared is 144, 16 squared is 256. Is this true? Well, let's check it out. We have 144 plus 256. This is 10, carry the 1. This is 10 as well. We do have 400. Does 400 equal 400? I think so. So we're going to go ahead and say, since it's true, 20, 16, and 12 will make a right triangle because it does follow the Pythagorean theorem. Okay, so at this point, I would like you to go ahead and pause the video and try the next 4 examples on your own. Okay, so let's see how well we did. Here, 11 was your hypotenuse. So you would plug it into your formula and find out that it was a false statement, which means it's not going to create a right triangle. Number 16, with 15 as our supposed hypotenuse, plug it into our Pythagorean theorem, we find that we do end up with a true statement, which means it will make a right triangle. Number 17 here, supposedly the 25 is the hypotenuse. If you plug it into the Pythagorean theorem, you'd find that you'd end up with a true statement once again, which means these lengths will create a right triangle. And then last but not least, here if 16 was the hypotenuse, if you plug it into the Pythagorean theorem, you'd find that it is false, which means it doesn't follow the Pythagorean theorem and it's not going to create a right triangle. That actually is going to conclude the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.